Okay, so I'm supposed to give an example in 12.6, number 26, of a function that's continuous. So I'm supposed to provide f with f continuous except at, what are the points? 0, 0, and 1, 2. Okay. Interesting. How do I do this? What am I looking for here?
Wait. For some reason I didn't hear the question. Could you repeat again?
Yeah, so I'm supposed to provide a function, f, that's continuous everywhere except at 0, 0, and 1, 2.
I can give you like the picture, but I can't give you the exact function.
Yeah.
Okay, so a picture, right? How do you how do you make continuous except at some points? What do you want to do?
Math.
Just tell me.
At the math lab, we kind of tried doing it like putting holes in the function, but when we did it, we ended up getting 0, 2, and 1, 0 as possible holes as well. Because,
Okay, so to make a function discontinuous at a point, what's the easy way? Like, you want to punch a hole in it, right?
You want a denominator that equals 0.
Good, yeah. Making a denominator equal to 0, right? Dividing by 0 is the easiest way to make a function discontinuous. Great. So, what I need to do is I need to figure out a way to make these 2 points cause division by 0.
So 1 over x for the center part.
Okay, so I might just start with f of x is, I don't know, what's your, oops,
X, y.
f of x and y, right? Okay, so start with your favorite continuous function. What's your favorite easy continuous function?
Z equals 0.
Yeah.
I'm going to start with z equals 1, but sure, yeah. Like, pick your favorite constant function.
Just 1.
So I'm going to start with 1, right?
Divided by x.
Okay, so if I divide by x, now I've got problems whenever what?
X is 0.
Origin.
Yeah, not just at the origin, but everywhere x is 0.
Oh, okay. Sorry.
Okay, see this? So I've caused problems all along the y-axis now. Uh-oh.
Okay, so it's too much.
Yeah, so that was a little bit much, right? Uh-oh.
Do you take away the x or add to the x?
Do X
Multiply by
Squared
y.
minus x.
Maybe?
Oh, X plus y.
That's still right there.
Yeah,
That doesn't change the problem.
Yeah, so this actually added more problems, right? Because now not only am I discontinuous along the x, or along the y-axis because of x is 0, I'm now discontinuous along the entire x-axis too. You guys see that? So like, maybe I should list my tries. So the first thing I tried was 1 over x. Right? And this has problems at the y-axis. Right? Really think x is 0. And then I tried f of x and y is 1 over xy, and this has problems at the
X and Y
x
axis.
and y axes.
Just destroy the entire.
So at least I got 0, 0 in, oh shit. Right, I had 0, 0 already
Well,
here.
you can kill 0, 0 with 1 over x plus y.
Oh, that's a great idea.
Or you could
Plus
use like,
y.
You guys see that? So if I did 1 over x plus y,
But then if x
Anywhere,
then this has problems
X equals
anywhere x
negative y.
equals minus y, right?
Which works at 0. That still works for the origin.
Yeah, so this one still has the origin, but it has problems entirely along the line still. So I tried this one, right?
Yep.
And this has problems at y equals minus x.
x squared over dx minus. How about
You guys see that?
what if we square that?
X squared plus y squared.
X minus.
Oh, that's a great idea. If I do x squared plus y squared, right? Then I'm doing 1 over the radius, right? And that only has problems when the radius is 0, which slims this out to the origin. Okay. Okay. So I think that worked. Now, how about the other
You
one?
just got a
So
different fraction.
right now I'm pretty pleased with 1 over x squared plus y squared because this only has problems at the origin, right?
At 0, 0.
But we need 2 problems, not
Okay.
just 1.
So, well, I'm halfway there though.
Yeah.
I would claim I'm quite a bit better than halfway there actually because
Yeah.
now I have a strategy. So what do you want to add to the bottom of this thing?
Well, some,
Minus 1.
oh, x.
You want to add an x minus 1
And a y minus 2. Is it a different quantity?
like this?
Yeah.
Square them both. Add them, and then.
Okay,
Let's
so
do this
hang
one
on,
by part.
let me just deal with the ideas as they can. So the first thing was adding x minus 1, right? As a factor on the bottom. So when is that going to have problems?
1.
Anytime x is 1, right?
Yeah.
So that's parallel to the y-axis, a whole line of problems.
That's not-
Okay, so that was again too much, right? That was back to this axis problem. And this other guy, when y minus 2 is 0, right?
Same thing with the x-axis.
That's similar, it's parallel to the x-axis and a whole line of problems. But I can get around this by doing the same trick that I did over here, right?
Scoring them.
I do, okay, so I'm going to do x minus 1 squared plus y minus 2 squared.
Nightmarish.
And then what I'm thinking here, right, is this first guy, right, was the radius from 0, 0, right? What's this other guy?
The radius from 1 to.
Good, that's the, well, really the radius squared. You guys cool with that? So this thing's only going to have problems when the radius from 0, 0 is 0, or when the radius from 1, 2 is 0. Otherwise, we're good to go. Question, what is this thing, what does this graph look like now?
It's probably a nightmare.
Anyone have a 3D calculator?
Okay, so what did this graph look like first, right? F of x and y, right, equals 1. That's the thing I started with, yeah?
Just a line. Or, hold on, no, not just a line.
That's a horizontal plane, right? At 1 high. So this is the point 0, 0, 1, right? The z-axis is here, and then there's an x and a, or a x and a y or whatever. You guys all with me on that? Okay, then I took and I divided by the radius from 0, 0, right? So let me think about that piece now. So this is like f of r and theta, right? Is 1 over r squared. Okay. What does that look like?
It's like the, it slowly.
Yeah, there's no theta, right? You guys see that? This is some kind of a, this is like a polar cylinder, right?
Okay.
So this looks like 1 over x squared spun around in a circle. So 1 over x squared looks like this,
Ah, so
and then rotate this sucker.
it's a tornado.
Cool. I'm liking to think about this like a circus tent, right? With a really tall pole in the middle. You guys see that? The reason I'm thinking about it like a circus tent is because that makes my brain do adding a peak really well. You guys see that? Right? That's all this thing is another peak in there. So this thing's going to look like, oh, there's going to be kind of one bit and then another one. You guys see that?
It'll
Cool.
be like saddle shape on top then, you're saying?
Yep. So there's probably a saddle in here, right? And then it's kind of decreasing everywhere else. We can check that later, actually, when we get to partial derivatives. We can check that's a saddle, but I'm pretty sure it is. It probably won't be that convenient parabolic saddle that we're used to, but it'll look similar. Cool? Questions, Steele? That help? What's up, Kenneth?
So the saddle one is what the final, graphics thing?
Yeah, so this guy is what this final thing looks like. Right, there's a,
Origin and
yeah, another way you could think about this is the gravitational field from two equal weight particles
It's like a binary star.
set a ways apart, yeah.
Does it,
It would be easier maybe if you looked at this picture upside down to think about that as gravity.
oh yeah.
Does the-
Wait, that almost looks like wormholes.
does the gravitational
Or-
pull go to infinity if you approach the? It is if it's a singularity.
So that gravity is proportional to 1 over the radius squared, so. There's some weirdness with point gravity sources, which is what I'm talking about here.
Okay.
You guys all recognize that I've done something a little weird by saying that this is gravity concentrated at a point.
Yeah,
But any answer that would give you a function that was non-continuous at both points would be fine, right? It doesn't have to look like that.
Yeah, and there's other ways to approach this. You guys all see that? Like the total cop-out answer to this, you guys want the total cop-out answer? Is to take this plane, right, and punch 2 holes in it,
Just say it's not defined.
and just write this, right? F of x and y is 1 except at,
Oh
right?
my gosh.
Oh,
that is a little piece.
And for the other one, just leave it undefined.
Could you actually show us what it looks like? 'Cause-
Oh, you showing
Just-
me right now,
just
it's a
for-
plane with 2 holes.
Yeah,
in
I
it.
would literally
Oh,
write
literally
that.
just write it? Oh,
Yeah, that's the cheese.
Or you can
that's
just write
cheesy.
plane
That's
and-
real cheesy.
Next.
Or at either of those 2 points, it can be any other number that's not on that plane.
Yeah, perfect. So you could also, instead of just punching holes, you could fill in the holes somewhere else. As long as they're not at the same level, this is fine. You guys cool with that? Okay, so that's the equivalent, right, of I would like to make this function discontinuous at this value. So I'll just take this and move it. Right? Because all you need is for the limit not to be the value. And the way you can do that is you can make the limit not exist, or you can just make the value and the limit different.
Or you can make 2 black holes like we did.
Yeah, or you can do this 1 over 0 thing. That's making the limit not exist, right? You guys see this? Cool? Questions?